आपकी सैटरडे को होगी, मैंने मेल लिख दिया है.
Okay, sir. Thank you.
Tomorrow there will be no tutorial class because sections are not subdivided. So your tutorial of infinite series will be discussed on Saturday. I think
Okay, sir.
I have written the mail. Assignment. Okay. Assignment 3 on 1 will be discussed on 11 a.m. Saturday. I will write one more time. There will be no tutorial class tomorrow. Okay. So now I think I should start. Yes. So I am starting lecture. So before starting new concept, one topic is left from infinite series. That is
सर
absolute.
आपका माइक म्यूट है.
Yes. Okay.
नहीं सर, आपकी आवाज आ रही है.
Now is it okay? My voice is coming.
Yes, sir.
Yes,
sir.
Yes, sir.
Okay. It says the alternating series that is n is equal to 1 to infinity minus 1 n minus 1 an is said to be absolute convergent. Absolute convergent if series n is equal to 1 to infinity mod minus 1 n minus 1 an converges. If you take the series of positive terms, then this converges. If this converges, you know this also converges, minus 1 ki power n and minus 1 an. Because we know if series mod an converges, then series n is equal to 1 to infinity an converges. So both alternating series also converges, or this series also converges. So you can say this is absolute convergence. Or it is sufficient to show that only positive series converges. You have no need to show that this series minus 1 ki power n minus 1 an converges explicitly, because we know a result. If mod an converges, then an converges. Now there are chances if this series n is equal to 1 to infinity minus 1 n minus 1 an, it may be a chance that this diverges and this series n is equal to 1 to infinity minus 1 n minus 1 an converges. Then this series n is equal to 1 to infinity minus 1 n minus 1 an is called conditionally convergent.
Sir, could you please explain the absolute convergence? I didn't get.
Yes, I shall. Conditionally. Absolute convergence says this mod an series converges as well as this minus 1 ki power n minus 1 an converges. So if you write only series n is equal to 1 to 3 minus 1 ki power n minus 1 converges, so it is sufficient because we know a result. If this converges, then this series n is equal to 1 to infinity minus 1 की power n minus 1 n already converges. You have no need to write that thing. Now, if this diverges and the alternating series converges, then you can say this is conditionally convergent. If you take the example, I have done both example, this series n is equal to 1 to infinity minus 1 n minus 1 over n square. This is absolute. This is absolute convergent. How absolute convergent? You can say if you take the positive series what will be? Series n is equal to 1 to infinity mod minus n minus 1 n square. So this is actually n is equal to 1 to infinity 1 by another. This is converges. You can say this is absolute convergence. Now, if you take the example, one more example, this series n is equal to 1 to infinity minus 1 n minus 1 over 1. This is conditionally convergent. Why this is conditionally convergent? I approve this series n is equal to 1 to infinity minus 1 n minus 1, and if you take mod this series n is equal to 1 to infinity,
क्लास चालू हो गई, मैं नहीं ना रहा अभी.
this is diverges.
नहीं.
Yes, Vardhan. Yes, Vardhan, mute your mic. And I approve that this by Leibniz test, this n is equal to 1 to infinity minus 1 n minus 1 over n. This is converges. So this series is conditionally convergent. Okay. If anybody has doubt, ask me. Otherwise, definition of absolute convergent is over. So this is so easy. There is nothing difficult. Now come to the next topic, that is continuity. So what is continuity? In a sequence, we considered functions whose domain was the set of natural numbers. Clear? Here, first thing is that we consider real valued function whose domain is any interval, open interval, close interval, any real interval. Okay? Now, what is the continuous? First, what come in the picture? Suppose you have a function. Suppose you have a real valued function from R to R. It may be any subinterval, subset, any closed interval or open interval. This is called continuous. What can you say? If it has a, what you say? If it has a continuous curve. It is called continuous if it has a continuous curve. What is the mean of continuous? It means continuous curve means you can draw, graph of f can be drawn without jump. What is continuous means? Graph of f can be drawn without jump. Or you can draw the graph in a continuous motion of the pencil without leaving the paper. Clear point out? So this is the continuity you can understand by geometric way. Now I am giving the formal mathematical definition. What is continuity? So first I am telling you the definition of limit. and I will tell you the definition of continuity and tell you what is the difference in the definition of the limit and the continuity. So first I'm writing the proper definition. A number L. Number is obviously real number because we are studying only real number is called limit. Is called limit of a function f at a point x naught if for every, be careful, for every epsilon is greater than 0, there exists delta is greater than 0 such that, how such that, mod fx
Sir, your voice is lagging.
Voice is lagging.
सर आपकी स्क्रीन भी फ्रीज हो गई है
सर आपकी वॉइस और स्क्रीन फ्रीज हो गई.
Is it clear now my voice?
Sir,
Okay.
यस सर
Okay, now it has been come. Okay.
सर एक बार फिर से बता दीजिए
I tell you, no doubt. My voice is coming or not, Chirag?
sir, now coming.
Yes, sir.
What it says, if for every epsilon is greater than 0, there exists a delta is greater than 0 such that mod fx minus L is less than epsilon whenever this condition is satisfied. Now, then, and we write limit n is tend to infinity fx is equal to L. Okay, now I am giving another definition. This is 2, now this was 1. What is the continuity? A function, suppose you have a function on defined on a subset of R is said to be continuous at a point x naught element of this B such that if definition is same as limit for every epsilon is greater than 0, there exists a delta is greater than 0 such that mod fx minus fx naught is less than epsilon whenever mod x minus x naught is delta. So what is the difference between limit or this? Sir, I have network issue, so I cannot end the class. Please mark me. Okay, Bhargav. So it is, what is the difference? Please see here, this is in the case of limit, 0 is less than mod x minus x naught less than delta. In the definition of this, mod x minus x naught is less than delta. It means limit of a function at a point can be defined if the function is not defined on that function, that point. Limit of a function is not, you can define at a point even function is not defined at that point. But if in the case of continuity, function must be defined at that point x naught, and the limit, and limit whatever be the limit, that must be same as the value of the function at that point. So if f is continuous at x point, then limit will be the value of the function at that point. If f is continuous at x naught, then L becomes is equal to fx naught. So difference of limit and continuity is limit can be defined without function is without not defining the function at that point. It is not compulsory that function must be defined at that point. But for continuity, function must be defined at that point, and the value of the function becomes the limit at that point if function is continuous. That's why you are taking also 0. The continuity definition is, this is the difference between continuity and limit. Or what is the definition of continuity? A function is said to be continuous at point x naught if for every epsilon greater than 0, you can find a positive number, say delta, such that whenever this condition satisfy x minus x naught, this will be epsilon. You will find delta for every epsilon. This now, if since x naught is arbitrary, if f is continuous at every point of D, then f is called continuous on D. Oh, this definition is known as, this is known as epsilon delta definition. So it means you have studied in your intermediate left hand, if function, if you want to check the continuity at x naught, find left hand limit, right hand limit, and the value of the function at that point. If the left hand limit and right hand limit is equal and it is equal to the value of the function at that point, then you say f is continuous. But in this course, we don't study definition of continuity, that is left hand limit or right hand limit. Here we study only epsilon delta definition, and there is one more definition of continuity that is known as the sequential definition. Second definition is of continuity, yeah, you can say third, sequential definition. What it says, a real valued function f sorry, is continuous at x naught element of R if and only if and only if whenever a sequence of real number, obviously real numbers, xn converges to x naught, then fxn converges to fx naught. So this is the sequential definition. A function is called continuous if at x point, if and only if you have a sequence of real number which converges to x naught, the fxn sequence will also converge to the fx naught. Then this sequence also converges to the, then you can write, then sequence. So I am taking an example. Okay, I will solve this example by both definition, epsilon delta definition and sequential definition of continuity. If anybody has doubt, he or she can ask. Otherwise, I am taking one example which, and that example I solve by both definition. Any doubt? No. Now let us take an example. Example is define a function. You define a function, suppose fx, such that it is saying fx is equal to twice x sine 1 by x if x is not equal to 0 and 0 if x is equal to 0. Question is, check the continuity at x is equal to 0. Okay. So now first I am solving by epsilon delta definition. After that I check the by sequential. Let epsilon is greater than 0 be given. Here now, what you have to prove, if you see the definition, mod fx minus f0 is less than epsilon whenever mod x minus x0 is delta. For each epsilon there must exist. So what we do, first find fx minus fx0. So here x0 is 0. You are checking the continuity f0. So here you can write this is 2x sine 1 by x, f0 is equal to 0, or you can write this is twice mod x mod sine 1 by x. This is, sorry, you are writing 0, so here you need to write 0 if you are calculating. This is you are calculating f0. So
Sir.
2x, now what you,
Explain, sir, how it is less than equal to.
Yes, sir. How divisibility is there?
this is not equal to. Right now, this is not. This is typing error. Fx minus f0, this will be less than equal to 2 mod x. Here, limit, mute your mic, since mod sine 1 by x is less than equal to 1. Okay. So here you can write this is 1. Actually, when you are applying the epsilon delta definition, if you recall, it says fx minus fx naught will be less than epsilon whenever mod x minus x naught is delta. X naught is 0. So whenever x minus 0 is less than delta, this condition must be satisfied. So for epsilon is greater than 0, you need to choose a delta. You need to show that there always exists a positive delta. So how you proceed? Choose. Delta is equal to epsilon by 2. Any epsilon is given, you take delta half of epsilon. This will be always greater than 0. Now, for every, whatever your epsilon is greater than 0, you can write there exists delta, which is equal to the epsilon such that, how? Whenever this x minus 0, which is mod x, is less than delta. If mod x is less than delta, what will be your fx minus f0? Fx minus f0 is less than is equal to 2. So this will be less than twice delta, which is equal to epsilon. Or you can say mod fx minus f0 is less than epsilon. So whenever you have delta, so this is finally you can say f is continuous f is continuous at x is equal to 0. The main point is, I am again repeating, fx minus x0. Right hand side, you need to bring a expression x minus x naught. And according to the scalar multiplication, choose delta. And you will always be in condition, in will be situation that you can easily check that there exists delta or not. If anybody has doubt, ask me. I will tell two or three more example on this. Okay, now I am telling you the sequential definition. Then I will take two more example on this, and it will be easily understood. There will be no problem according to me. Sequential definition.
सर एक बार वो बता दीजिए कि डेल्टा कैसे दिया?
What is delta? Actually, if you see the definition x minus x naught, this will be x minus 0 delta. So here 2, so whatever mod x, here is mod x. So if I take epsilon delta is equal to epsilon by 2. So mod x I have this is when you apply this, when you use this condition in equation 1, so fx minus f0 will be less than epsilon. So you can choose delta epsilon by 2. Meaning of this, whatever you take epsilon, you immediately take delta is equal to epsilon by 2. And you will get the expression. So it means for every epsilon, you have found a delta in terms of epsilon such that whenever mod x is less than delta, mod fx minus f0 will be less than epsilon.
सर अगर डेल्टा कैलकुलेट नहीं हो रहा हो तो
फिर नहीं कर सकते। No.
फंक्शन नहीं ऐसा मान लेंगे।
देखो, इफ डेल्टा कैलकुलेट नहीं हो रहा हो तो हो सकता हो आपसे ना हो रहा हो, अगर और कोई कर देता है देन यू कैन, तो हो सकता है कंटिन्यूअस हो। अगर नॉर्मली हो ही नहीं सकता देन यू कैन से दिस इज डिसकंटिन्यूअस।
ओके
ओके, तो आई एम टेकिंग टू मोर एग्जांपल, जस्ट वेट अबाउट द डेल्टा। ओके, नाउ एप्सिलॉन del sequence, let xn be a sequence, obviously real sequence converges to 0. Okay, now I have to prove fxn converges to f0. So let epsilon is greater than 0 be given, any number is given. Okay, now here I will write another thing here, but later I will tell you. Okay, I will leaving blank. Then since you can write here, since xn converges to 0, so for here I am saying a blank, don't here, there exists a for every positive number, actually here is positive number, there exists a natural number n such that how mod xn minus 0 is less than, here you can write positive number, here you can write anything. So here I am leaving this blank for all n is greater than m. Clear? This is the, I will fill this later. Okay, now we are to show what we are to show, fxn converges to f0. So find mod fxn minus fx0. This will be mod xn, so again this will be 2xn sine 1 upon xn. So here mod fx minus f0, can I write directly 2 mod xn? So here I have to prove mod fxn minus f0 is less than epsilon. So here is 2. Here is 2. So what should I do? Mod xn is this. So here if I write, here if I write this epsilon by 2, so it will be, you will get from 1 and 2 you can write, what you can write? Mod fxn minus f0 less than epsilon for all n is greater than m. You can write from 1 and 2. That's why I didn't write anything. I will fill other things also. So fxn converges to f0. So f is continuous at x is equal to 0. So now same thing here will be epsilon by 2. So this now come. What should be here? Actually, you consider epsilon is greater than 0. So since action converges to 0, you can write this will definition of convergence also will be true for epsilon 1 for every positive number. So here you can write this is suppose epsilon 1 is equal to this. So why I write there is no need, because you can easily see that f(x1 minus f0 is less than epsilon for showing you. Otherwise you can start from epsilon, so here will be 2 epsilon. So there is no problem. After here you can also write since action converges to 0, in some books it is written action is equal to 0, then fxn minus f0 will converge to 0, or fxn converges to f0, like that. In some books they write in this form in a nutshell, but here I am showing you how you can express in terms of epsilon for your better understanding. Limai Gorbet, they directly write in this way. There is no problem after that. If anybody has doubt in sequential, Kartike, is my voice coming or not? I'm seeing coming. Yes,
Coming.
it-
No, sir, it's clear.
Sir, I rejoined, so it's fine now.
now it is fine. Na? Sir, एक बार explain again, Sri Raj. What from where, Sri Raj? What I am saying here, mode accent, so 2 mode accent, so that's why I write epsilon by 2 for bringing expression in epsilon. Otherwise, you can write epsilon or this. Here I consider epsilon is greater than 0. So since action converges to 0, so you can write any number epsilon by 2. So I am checking for epsilon by 2. So there exists a natural number m such that epsilon by 2. Now f(x1 minus f0 will be 2 mod x1, 2 mod x1. So 2 and 1 if you combine, so this is less than equal to epsilon. Clear? What I did, epsilon is greater than 0, आपको ये प्रूफ करना है, तो मैंने कन्वर्जेंस की डेफिनेशन इसके लिए लगा दी. ये भी तो एक पॉजिटिव नंबर है epsilon by 2. क्यों? क्योंकि यहाँ 2 आ रहा है, 2 is coming. So expression will be looks like in terms of epsilon. Just wait. Hello? हाँ कौन? हाँ हाँ जल्दी बोलो. हाँ गेट पे दे दो, आप गेट पे दे दो, मेरी क्लास चल रही है. हेलो, तो भैया आप गेट पे मित्तल कॉलेज में दे दो ना, अभी मेरी क्लास चल रही है 2 बजे तक. हाँ आप गेट पे दोगे ना. ओके सॉरी, एक्चुअली दिस इज द इमरजेंसी कॉल फ्रॉम अमेजन, अगर अन्यथा वो चला जाता. ओके दिस इज. तो एनी डाउट?
No, sir.
Any student? Ishan Sharma?
No, sir. No, sir.
Okay. Now let us take one more example. It will be clear from this example quickly. After that, I will take one more example. Then there will be no problem in epsilon delta. How to choose delta and epsilon. Suppose you have fx. This is x square. And define on 0 to infinity, semi open interval. Sorry, -1 to 1. Question is check continuity at any point of this. Okay, now solution, let epsilon is greater than 0 be given. Okay, and x naught -1 to 1 be any arbitrary point. If I prove for x naught, so I can say this is continuous at every point. That's why I consider arbitrary. Now, epsilon delta definition fx minus fx naught. This will be x square minus x naught square. I told you try to bring the expression in terms of x minus x naught. So here this is c square minus d square x plus x naught. Sorry. You can write this is x plus x naught and x minus x naught. C square minus d square. You can write x plus x naught and mod x minus x naught. Now, this is fx minus fx naught. Can I write this is by triangle inequality mod x plus mod x naught? Sorry. This is and mod x minus x naught. Again, fx minus fx naught. This is, can I write 2x minus x naught? Why? Because since x and x naught is the element of -1 to 1. So mod x will be less than 1. Similarly, mod x naught will be less than 1. Now suppose this is 1. Again, you have an idea what you need to choose. Choose delta is equal to epsilon by 2. X minus x naught. Here is 2, which is positive 0. Whenever epsilon is given, you take delta epsilon by 2. So, for given epsilon is greater than 0, there exists a delta value of is this such that if you have this is minus delta, the value of this fx minus fx naught, this will be less than 2 delta. Yeah, you can write more precisely. You can write this is 2x minus x naught, or you can write 2 delta, or this is equal to epsilon. In this way, you can understand in better way. Now it is clearly. So whenever x minus x naught, so f is continuous. At x naught, last line you can write, since x naught is arbitrary, point. So f is continuous at continuous in this interval minus 1 to 1. So if anybody has doubt, sir, if epsilon is 2 mod Naman, 2 mod x minus, then how mod x minus s is less than delta? If epsilon is 2 mod x minus x naught, मैंने लिया ही नहीं है, 2 mod x minus x naught should be less than epsilon. See, x minus x naught delta. So fx minus fx naught is 2 delta. A value of 2 delta is epsilon. No, okay. Any other doubt?
सर वो इक्वेशन 1 में 2x माइनस एक्स नॉट कैसे हो गया ऊपर से, सर वो बता दीजिए.
See, this is mod x plus mod x naught. There
Yes.
is no problem.
Yes,
What
sir.
is the value of mod x? Maximum value of mod x can be less than equal to 1 because x is the element of minus 1 to 1. पॉइंट जो है वो x में ही है ना, माइनस 1 to 1 ही हो सकता है ना, मैक्सिमम वैल्यू तो 1 ही हो सकती है. x और x नॉट तो माइनस 1 और 1 से ही तो ले रहे हो आप.
ओके सर.
Okay.
सर
Any other doubt? No. Now let us take one more example. Any doubt?
No, sir.
Nimit. Now example 3. Let you have a function fx is equal to sin x and define d is equal to taken 0 to infinity. The question is check continuity, sorry, continuity at in this interval. So same thing, solution is let epsilon is greater than 0 be given.
सर यहाँ पे d का मतलब डिफाइन है क्या?
अरे d एक सबसेट ले लिया ना, यानी
अच्छा, सबसेट. और सर ये
f
दूसरा,
is the subset of R to R.
और सर
Can
ये
you
0 से
don't-
इंफिनिटी के बाद ब्रैकेट उल्टा क्यों लगाया?
f is defined on this to R. Okay. Is it open because infinity does not include in an interval.
अच्छा,
This
तो वो
is
सर
open.
कर्ली ब्रैकेट आ सकता है ना इंफिनिटी के बाद?
Oh, this is the symbol, or you can write like that. 0 to infinity, this like that.
अच्छा, सिंपल है.
They are same. Open.
Okay, sir.
Same thing. Okay. And x naught, मैं यही लिख देता हूं. That will be good. This is be any arbitrary point. Okay, now again find fx minus fx naught. So this will be sin x minus sin x naught. So sin x minus x naught, it is same as, Karthik, sin x minus sin x, formula of sin c minus sin d. So sin c minus sin d, I am writing, you can note down, x minus x naught by 2 into cos x plus x naught by 2. So here you can write 2 mod sin x minus x naught by 2. Since cos x is less than equal to n. तो दिस इज fx minus fx naught so I told you you need to bring expression in terms of x minus x naught. So here can you write this is 2 into x minus x naught by 2? There is a condition mod sine x, this is less than equal mod x. I think for small x. So x minus x naught is small because x is approaching small. X is approaching to x naught. So finally, you can write fx minus fx naught. This is x minus x naught. This is 1. Now you can do it easily. Same thing. Choose delta. Here x minus x naught. So you need to only epsilon. Is greater than 0. So for epsilon is greater than 0, there exists delta, which is equal to you take epsilon such that mod x minus x naught whenever this is true, what will be the value of mod x minus fx naught? This is less than delta or is equal to epsilon. So you can write mod fx minus fx naught. This is less than epsilon. So finally you can say f is continuous at x naught. Since x naught is arbitrary, point, so f is continuous if anybody has doubt ask me. So I did some question on the continuity using epsilon delta and sequential definition. Today lecture is over. If anybody has doubt ask me.
So can you show one example where the function is not continuous and we confirm it by this method?
In that you cannot find this. Just wait. Hello? How are you? हाँ दे दो एक मिनट जस्ट वेट प्लीज स्टूडेंट जस्ट वेट अरे ओटीपी आया नहीं भैया in that example if the function is not yes अरे यार तुम बावला क्यों बना रखा है यार एक्चुअली मैं ये वापिस चला गया बार बार परेशान कर रहा है हाँ actually if function is not continuous then you are saying give an example. I will give you because due to the lack of time you cannot find delta. You will not be able to find delta if it is not continuous. You will be stuck. I will give you the example in next class when this is you cannot find the delta. Okay.
So please add the PDF and recording of this class.
बेटा वो तो मैं रोज ही भेजता हूँ ये कौन कह रहा है सेंड द पीडीएफ आज तक 13 लेक्चर हो चुके हैं सबकी वीडियो सबकी पीडीएफ मैं इमीडिएटली भेज रहा हूं बेटा हु टोल्ड दिस नाम बताएगा अपना कोई किसने कहा है ये बेटा या आप नए ज्वाइनिंग हो अभी इसलिए आप कह रहे हो